Welcome to the Demystifying Technology Podcast from the MacLaurin Group.
Typically, you go through the due diligence process. What the world of private equity is.
Can't wait. Demystify it.
We talk with Kirk Pepperdine, co-founder of jClarity, a Java-based performance tuning company that was recently acquired by Microsoft. Discover the evolution of jClarity and how bringing a structured performance model using machine learning for tuning language runtimes led to success and an exciting future with the most unlikely of Java bedfellows, Microsoft.
Welcome back to another episode of Demystifying Technology, and today I'm horrendously excited because I've got my old friend, the Java Champions champion, Kirk Pepperdine with me. Kirk, how are you doing, my friend?
I'm doing just fine. I'm just trying to get adjusted to my new role and generally just fine and just loving it. Just loving life. That's what we got to do, right?
Being a Canadian, you've got that wonderful, you've got a little bit of British there, saying you're underplaying stuff. Your life has changed quite dramatically over the last couple of weeks, has it not?
Yes. Our company was bought, shall we say, lock, stock, and barrel by Microsoft. So
that is absolutely wonderful news.
We're now Microsoft droids.
So this is jClarity, the passion that you and Martine have been working on for what? How many years now has jClarity been officially incorporated?
The company is like 8 years old. The ideas and everything that came in to form the company obviously are much older than that. So as I think Jack Shirazi, one of my older cohorts, has said, yeah, you've been preparing all your life for this.
Yes. So just to give people a bit of background, Kirk is a Java champion. He's also the world-renowned Java performance guru as well. So where mere mortals think that their Java application is tuned and specific and they've gone through every single README they can find on the internet to make it sing as fast as possible, that is merely the starting point to when Kirk comes in and does his magic. So where did the idea for jClarity come from?
Do you want me to tell you the truth, or do you want me to tell you the marketing line? The idea for jClarity came on a flight from Frankfurt to Cape Town. Well, the germ of it, yeah. So Dr. Heinz Kibbutz and myself had to give a talk in Johannesburg, and so I was traveling to his place. And so basically what I was doing is I was trying to figure out a way to model what it is that I wanted to speak about. I've been thinking about this for a while, and basically, I went to sleep on the flight. Halfway through the flight someplace, no idea where, I woke up, took out my notebook, scribbled down the model, and then went back to sleep, landed, got up, went to Heinz's place. I said, I scribbled this stuff down. He looked at it and says, that's completely brilliant. And I said, okay, that's kind of cool. And what it was is it was the basis for describing a model. And what I did with that is I basically described performance tuning in a nutshell. The model was so succinct, and it works. I've been able to teach that model to literally hundreds of Java developers and operational people, and they use it quite successfully. Anyways, the model was so succinct. When we finally got teaching it to Martin, we all just looked at it and said, you know what? This is so algorithmic now, with a few fuzzy places here and there. We can actually use machine learning to cover off the fuzzy areas. The algorithmic stuff is like, it's an algorithm, so we can just implement it. So we went off and found a fairly clever machine learning type person. We brought him on board into the company that we formed around this idea.
Okay,
and then we started building product.
Before you get too far ahead of things here, so we've got this eureka moment, and some say this is how Elton John also discovers some of his songs. He wakes up, pencils them down, and comes back in again. So how did you know that what you had in your hand was worthy enough to build a company around it?
We didn't, actually.
So how did you
quite honestly.
How did you prove it then?
I knew that I could follow the algorithm, and it got me good results. And I knew others could follow the algorithm, and it got me good results. And it was so algorithmic that there wasn't much thinking involved with it. So it was pretty much all data driven. And all I needed was the thing I was missing was the data-driven component. And once we had the data-driven component solved, we had an engine that actually was doing what I was able to do in about an hour. I would do it in about 10 to 20 seconds. That's when we knew that this thing was just going to work.
Okay.
After that, it's just a matter of time for maturing.
Brilliant. So let's give a little bit of clarity here. Sorry, I used the word clarity there again. For our users, we're talking about JVM data here, aren't we?
We're talking about a process that actually understands what your resource constraints are and knows how to map that back into an application. Now, we're focused on Java, but it doesn't work just for Java. It works for any runtime you want to apply to it. It works for .NET. It works for Python. It works for C++ applications, native applications. The methodology is at such a low level that it really doesn't care about the application, what it's written in. Okay. What we end up doing is we end up implementing it for Java, right? We had to tool it up for Java for the JVM and stuff like that. So when we actually understand what's gone wrong, then we need to get more metrics out of the JVM.
So for those that are not as technically minded, from a developer's perspective, or even an IT DevOps perspective, what are we trying to get to here with this model?
We want to understand what the resource constraint is that's causing performance regressions in your application.
Right.
That's all we're trying to do.
And where are you collecting that data from in order for you to inform that algorithm?
The hardware.
The hardware.
The hardware. We collect it directly from the hardware. We look for patterns of different component utilization within the hardware, and we can use these patterns to infer what the actual problem is in the application.
So what sort of things are you looking for there, or what sort of things do you uncover then?
Well, I want to look at how the CPU is being utilized as a primary key indicator. Once I know how the CPU is being utilized, then I can take that information, I can use that information to infer what the underlying fundamental problem is. And then we're going to take that and start instrumenting the environment to try to understand what the application is doing, or why is it actually consuming the hardware in that particular pattern.
Right, and you'll eventually trace that back to a piece of source code that's doing something.
That's exactly correct. Eventually, we're able to map that back to a piece of source code that's actually doing something. And this whole process takes anywhere between 10 to 20 seconds. So as soon as we see a regression, 20 seconds later, we generally map that back to a piece of code in the runtime.
Now, historically, you were doing this by hand, weren't you?
That's correct.
And this model effectively gave you a mechanism to which to make it a bit more procedural.
Yeah, as I like to tell the people who I'm teaching the model to, I say, okay, so when we give them an actual real problem to solve, I say, okay, turn your brain off, stop thinking. In other words, just let the measurements and the data drive the direction of the investigation, and don't go anywhere that the data is not telling you to go. So
yes, because that's always the biggest problem when you're debugging or tuning, etc. Is you follow hunches, and most of the time those hunches are sending you down blind alleys.
Right. Well, I call this the drunkard's walk. Right. It's basically there's a probability you're going to be right, and there's a probability you're going to be wrong. And what I want to do with the methodology is I want to narrow that probability, hopefully to zero. The probability of being wrong, I'd love that to be zero all the time. And we're pretty close to that with this algorithm. I think we're in the high 90s in terms of being correct, so single digits in terms of being wrong, which means that we've eliminated a lot of the uncertainty in the performance tuning exercise, which means that I can now fix cost engagements to do a diagnosis.
Right. Now that huge boost.
If you tell people that you're going to fix cost, a performance engagement, I had a client basically refuse my fixed cost bid because they just looked at the whole thing and said, nah, we want you here until the job is done. So we don't want any. So they basically forced me to charge an hourly rate, even though I offered a fixed cost to them.
These are some of the things you have to do when running a business.
Yeah, well, I was going, okay, fine with me. I don't really mind. In that case,
sometimes right. When did you think that you had enough to bring a fully incorporated company and start actually productizing this?
Well, the funny thing is, I always figured that there was a way to create an application to do what I was doing, given that we had the strong methodology, is really when I met Martin, showed him the whole thing. He was with Ben Evans at the time. They just looked at each other and said, we know people that can help us basically implement this. Bit of hubris or whatever, belief in ourselves, where we just looked at this whole thing and said, yeah, we can do that. We basically had a 2-year experiment where we're playing around with different ways to deal with some of the fuzziness in the algorithm. So, and to validate some of the magic numbers that I intuitively had come up with in my engagements. So machine learning was used to validate all of the models, and then we used other techniques that are not machine learning based. They're not big data based, so that we could actually have a daemon in the runtime that would actually do the diagnosis for you. And the fun thing is about this daemon, it's very, very, very minimalistic. It uses practically no resources on your system in terms of it's a extremely small footprint, almost immeasurable CPU utilization, and network usage from this, or disk usage is zero, and network is almost immeasurable. So it just sits there doing nothing until there's a regression, and then it might get a little heavy at that point, but at that point, you're suffering from a regression. So it doesn't really matter. But the whole point is the engine will go into the environment, sort out what's the nature of the performance problem, and then take that information and sort out a way to map that back to the code that's executing in the environment. So it's targeted towards Java, but it doesn't really have to be a Java application running in there. I've used this methodology against Lisp, against all kinds of different runtimes. We've talked to the .NET team about it, and they can see it's applicable there. It's not just specific to Java. It's specific to how is your application consuming resources, where's the constraint, identifying the constraint, and then trying to map that constraint back to some consumption pattern that the code is actually causing. That's responsible for that particular consumption pattern in the hardware.
Right. Okay. So it's one thing to build a company and a bunch of guys having a dream, but when was the first time you realized that, hey, people are going to pay for this? People are paying for this.
I always figured we were going to have an education problem with this particular product because it's so different than, well, when we first went in to talk to people, they're saying, so what is this? Is it APM? We're going like, no, not really. So it took us a while for us to come up with a name for it. So now I call it a diagnostic engine, right? It's not a profiler. It's not APM. So one of these things that not something that people have seen before. And the problems of people, if you don't have a name for something, then
you get pigeonholed into a certain thing, etc. But this was more for a production live environment as opposed to a developer's machine, which is where an awful lot of those terms are usually lumped towards.
Well, this is for a production environment, exactly. And so I said, this is a diagnostic engine. It's not going to work like anything you've seen before, right? Because you're not getting gauges and dials and fancy, the big screen, right, with all of the graphs and charts and everything flying by, and you're just looking at numbers and things like that. This is if you get a regression, it goes in, it does a diagnosis, it tells you, and it gives you a little report as to what it's found. And if there's nothing going on, there's nothing going on. It doesn't really give you the views that people are used to looking at when they're looking at an APM tool. And that turned out to be a problem because people were looking at this going like, okay, so what does it do? Right? It's not doing anything, right? And you're going, yeah, that's perfect. It's not supposed to do anything unless you have a real problem, which is really hard to demo. And then so you demo it, right? And you run into all these other problems, which are very interesting because, like I said, it's a real education problem. We went into these groups and they said, oh yeah, so here's a bunch of applications that we mocked up. They're running in AWS or wherever we had them running, or wherever they're running, some cloud environment. And each one's, jiggered up to have some problem in it. And so we run it, and the tooling goes through, it finds all the problems, in all the JVMs. The comment you get back from the customers or potential customers are, oh, it can only find those problems, right? I'll distill it down to, oh, it's only good for solving those problems.
Right.
The answer is like going, no, this thing is actually finding problems that we didn't actually design it to find. So when we apply it against real systems, we find that sometimes it takes us in areas where we didn't expect it to go simply because we hadn't actually ever tested against that type of problem.
Yeah, and I think that's
So-
that's the difference that probably is worth highlighting to our listeners here, is that what you've got isn't basically a bunch of if type statements where you're looking for specific things. You're learning. Each engagement makes you richer.
Well, actually, Alan, no, that's actually not the case in this case. It's actually more fundamental than that, right? We understand what the hardware consumption patterns look like, and so we're basically doing pattern matching against the hardware, right? And what makes this thing so cheap is that our sample rates don't need to be very high, and getting counters off the hardware is incredibly cheap. We can do that almost for free.
Got it.
And if you look at traditional APM often requires as much or more infrastructure to support than your application needs because of how they instrument. And even there, when they're instrumenting for something, you look at every single profiling tool on the planet, every single monitoring tool on the planet comes with this huge built-in bias. One of the favorite tools now, emerging favorite tools in the Java space is Flight Recorder.
Mm-hmm.
We had a session at jClarity this summer with Marcus Hurt, who is an incredibly, I have the world of respect for this person. He's built an incredible number of things that we use every day. And he built Flight Recorder. Our complaint about Flight Recorder, and my complaint about Flight Recorder, is that it is a huge bias in it's what Marcus or Marcus's team or other people that have contributed think are important issues that we want to monitor for. So it has all of this bias built into the tool, which means that if you run into a problem that they haven't thought of, the tool's likely not going to find it.
Yes, and that's what I was meaning by my if statement marks. But you're right. You're calling it bias. I'm calling it if statements. But yes, they're looking for specific patterns or specific things, and if it's not there, it's not going to be found. Or if they don't know about it, you're not going to. So they need to know what's wrong before to be able to tell others what to look for. Kind of like
exactly. And in that case, what happens is that when they find something new, then you have to go re-instrument for that particular thing, right? So you're basically iterating over an infinite list of things that can go wrong. Yeah. So if you look at our tool, and this is the expression I've come up with, right? There's an infinite number of things that can go wrong, but only in a finite number of ways. So I want to convert this problem from the infinite to the finite because I know I can. It might take time, but I can iterate over finite.
Right. Yep. Eventually got through the demo stage. You convinced them to hand over some cash and to install this thing. What was the first client success coming back to you that all give you that sort of, whew, this thing works?
Actually, Rightmove, I think, is one of our best clients in the sense that what they like is the tool finds things that matters to begin with. And secondly, I think what they like is that because of the way we set this up as a service and we have the dashboards that are, in our case, are basically web-based, we can actually do ops for them. So quite often, we would send them an email saying, like, you've had this problem on your system. It's this. Try doing this. This will probably fix it. And we're sending that information back to them before they even know they have a problem in their system, right? And we're able to do that because the tooling is giving us all this wonderful information. We don't have to have access to the systems. We're just taking the diagnosis that the tooling is giving us and putting it into a little bit of context and shipping it back to them directly. And then they can take action, and then all of a sudden their life is just a lot easier. They're looking at this going like, wow, we used to go through weeks-long cycles with operations to try to figure this out. Now we're getting answers back just a few minutes or within an hour when the incident occurs, no matter what happens.
So what sort of things are you finding, Kirk? Well, what's the...
Well, the list can go on very, very long, but I think that the biggest problems that we face today are the ones that have the least visibility. And the biggest problem we have today in most systems that we encounter is just simply one of memory churn, right? Mm-hmm. You can get, in some of the applications that we've gone in and examined, we've been able to see not 10 or 20% improvement in performance, but 2x or 4x
Oh, wow.
improvements in throughput. So this is a fun thing because, you've nailed the primary bottleneck in the application when all of a sudden you go 2x or 4x or faster or 5x faster, something like that. And you keep getting these gains until you hit the speed of hardware.
Right.
And that's typically I would say about 60% of the applications we encounter have a memory churn issue.
Yeah, I remember you telling me a wonderful anecdote a long time ago where you would say to me, you never understood why people thought a CPU running at 100% was bad. He says, well, why wouldn't you want your CPU to run at 100%? You've paid for it. Get the usage out of it. But yet, that's usually the metric that if our CPUs are 100%, that says, oh no, infinite loop, something's gone wrong.
Yeah. Well, to be quite honest, I was being a bit facetious because, of course, we like headroom for fluctuations in load and things like that. Obviously, you need some.
Like, don't kill a good story on me, okay? I'm going to keep saying that one.
Yeah. But it's quite true, though, isn't it? I mean, people are complaining, going oh my God, my CPU's at 100%. We need to do something, and going yeah, probably.
So typically,
anyway.
what's your sweet spot when it comes to sort of size of organizations? Where does this thing excel?
In terms of the tooling, we have customers that are very large, and we have customers that are very small. Everybody's interested in it because some of the skills that we actually bring to the table or some of the skills that are covered off in the tooling, even large organizations have trouble getting them and retaining them. Small organizations just can't afford to have them on board because they're too highly specialized.
Yeah.
A lot of the skills that these companies need, they should be renting them, actually, in my opinion. And a lot of the operations stuff, I think the way we're doing it today can be radically changed. But in order to radically change it, we need smarter tools. And so we need tools similar to Illuminate, which is our primary diagnostic engine. It was leading us in a direction where we could actually offer operations as a service. Right. And we could do that across an array of clients. And quite frankly, that's one of the value points I think we're going to bring into Microsoft is that, for if you're running in Azure, today would be a Java application. What will happen is that we're just going to hook this into there, target it for there, and hook it into the wonderful pipeline that they've built for managing all of this data that they're collecting to ensure people have good experiences in their cloud environment. Being able to do it there means that we actually solve a bunch of problems because deployment environments across the planet are it just made things very difficult, especially for us being a small company. But having something like that where we can actually target the tool means that we can have this thing do better than we were in the environment we were actually in.
Logistical barriers getting in there. So you bring us wonderfully onto the point of when did your new bosses start to come knocking on the door?
Well, there was a confluence of events that actually brought us together with Microsoft. One of them was just simply the change of licensing terms that Oracle, brought upon our world. It created an opportunity for us. So part of our team was already involved in the Adopt OpenJDK program. Mm-hmm. So we built the build farm for Adopt OpenJDK alongside the London Java community. So, and Martin is basically, he's got some fancy title there, but basically it's him and a couple of other guys are on the committee that actually run that whole thing. Microsoft was interested in that aspect of things, and they were also interested, of course, in our tooling and our expertise in this particular area because they are very interested in Java. They're interested in making people's Java experience better.
Which is a fascinating thing to say. Like we've both been through the Java wars, and to even have somebody say those words out loud feels strange, doesn't it? That Microsoft are now the ones championing and helping the Java community.
I have to say that if I actually didn't believe in Microsoft's mission, we would have just said no to the whole thing and just not engaged. But Microsoft really came to the table with this, with the story that they're committed to the Java community They're committed to Java itself. And of course, everything has to make sense within, Microsoft's businesses, but we do have a lot of leeway in terms of how we interact with the community. Some of it I'm not sure if I can talk about now, but all I can say is that if I personally didn't believe that Microsoft was committed to this particular project, then I don't think I would have signed up for it. So,
No, it's very
and
exciting.
we have been through the wars. Sorry.
And Microsoft, like they have done a phenomenal job sort of gearing up and doing major catch up when it comes to the cloud side of the fence. AWS looked to be the only horse in the race, but Azure is coming up very fast and in many respects a welcomed runner in the race in order to keep AWS on its toes. And it's such a wonderful thing to hear that they're committed to not only supporting their own stack, but also moving towards Java and others. I think this is wonderful, and by bringing in teams like yourself, it's validation that we've got to listen. And we're all a little bit suspicious when they bought over GitHub, thinking, what are they up to? But they genuinely seem to be going in the right direction.
I completely agree with you. I mean, when they bought GitHub, it was one of those things where you were saying like, okay, what's going on here? I think it was like, that's the end of GitHub or something like, very cynical like that. But in actuality, no, that's I would say that cynicism quickly melts away when you understand what it is that they're doing right now. And like I said, I think even Martin and myself, I mean, if we really didn't believe in what they were doing, we would still be independently operating right now.
That you two are both very big names and well-known names in the Java community. It's a wonderful validation that is indeed correct, what you say. It's
really exciting because there's things that we wanted to do in the Java community that we just simply couldn't because, we just couldn't. It was just too difficult. We weren't at that point yet. And I think we were working towards that point, and we would have gotten there. But this is just going to allow us to be involved in different areas that we need to be involved in just sooner. And we're going to be able to bring a bit more to the table than we have been able to in the past. And so I'm really excited for that opportunity. Well, it's been absolutely wonderful. I think what I'd like to do is to bookmark you now and say, right, okay, in 12 months' time, we're going to have you back on again because I want to hear exactly what happened in the next 12 months because I know it's still, the paint is still on the wall at this precise moment, and you're still getting yourself settled in, getting your new email addresses and all that sort of stuff squared away. And I wish you all the best, my friend. I mean, wonderful work. I know how much you've put in and how many miles you've traveled doing your teaching and basically plying your trade. And this is wonderful validation that you deserved every part of it. Thank you, Alan, for all your kind words. I mean, you've been a great supporter of me right from, I think, not very long after we met so many years ago. And I've always appreciated your wisdom and support and enthusiasm. One of the most enthusiastic people in this industry that I know. Thank you very much. And with that, Kirk, thank you very much for taking the time to talk with us. And thank you for listening to me.